Okay, hello everybody. Welcome. So we're kind of in the home stretch here. Just a reminder of where we're at in terms of the course. Today's the first day of April, so that means that we basically got, I think, 4 weeks of class left. Last day of class is, I want to say, like the 28th of April or somewhere in that ballpark. So we're getting pretty close to the end here. A couple things I wanted to make you aware of before we hop into today's topic. I've been trying to get the grade book cleaned up. So I've been going back through, making sure everything looks good on my end and make sure everything that needs to be graded has been graded. I would appreciate if you would do the same thing. Take a few moments to check over the grade book. As far as I know, it's in good shape. Everything that needs to be graded has been graded. All of the scores are in there, but mistakes happen. So I would appreciate it if sometime in the next, before the end of the semester, you take a peek at Canvas, make sure all your grades in there look correct. Happy to fix any problems that you find. Just want to warn you that I am not very forgiving about these requests coming in, after class is over. I'm a human being looking forward to summer break as well. Please do not sit on this kind of stuff. It takes 2 minutes just to check, make sure everything looks okay. Let's get that fixed up sooner rather than later. In terms of this class, we've got 2 more topics. So I've got today's topic, and then next week's topic, and then that's it. That's all the new material that I'm going to introduce. We'll have an exam review session after that for exam number 3. And then I just want to make it clear that there is a final exam in this class. It is cumulative. I've had some questions about that final exam. Just so everybody knows, it's in the course policies, but I'll remind you that we drop your lowest exam grade. So what a lot of students do, if they like their scores on exam 1, 2, and 3, they'll choose just to drop the final, i.e. not come, not take it. I don't have a problem with that. That is totally 100% A-okay with me. If you are happy with your grade after exam 3 and all the assignments are done, then cool, awesome, happy for you, that's great. If you dropped an exam earlier in the semester or you didn't do so hot on one of the exams, then come take the final. It cannot hurt your grade. It can only help you. Taking the final exam will not hurt you in any way, shape, or form. It can only make your grade go up. So just want to make sure you're aware of that. Does anybody have any questions about grading, logistics, end of semester stuff before I hop into inheritance, which is today's topic? Any questions? All right, fantastic. So today's topic builds very, 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 very heavily on last week's topic. And in fact, that's going to be true of next week as well. In fact, as I was just saying to somebody before class, pretty much any computer science course you take after this one is going to assume that you have some general knowledge of objects. I do understand that objects are kind of abstract. It's actually a very different way of thinking about our programs compared to the first, 2/3 of the course. So if you're still struggling a little bit with objects, that's perfectly normal. I remember struggling with objects when I first learned how to code. It's a tricky concept to wrap your brain around. Keep practicing. We'll get some chance to, I think, review those concepts today as we go through as well. But I am going to introduce a new thing on top of objects today called inheritance. So in order to understand inheritance, I'm going to first start by reviewing the 2 things that you can find in a class. What are the 2 things you can find in a class? Anybody remember? 2 categories of things I expect to see in a class. Yeah?
Instance variables and constructors.
You're very, very, very close. Instance variables, I like. Constructors is like 50% of the way to the second part. Yeah?
Methods?
Methods, yeah. Of which constructors are methods. So yeah, perfect. Constructors definitely qualify. Instance variables and methods are the 2 things that we expect to find in our classes. And there's a relationship, right? I talked about this last week, but it's a good time to review that in English, I say that there has a relationship between the instance variables and the class. So a person has a name, person has an address, person, has feather color. That sounds a little weird. People don't have feathers, so that's not a good instance variable for a person class, right? There's a relationship between, what a class contains, or what a class is, and the instance variables that it contains. And then as far as the methods go, there's also a relationship there. Those are behaviors. Those are actions that can either be performed by that class or performed on that class. So methods are the verbs, the actions that take place. The reason I bring that up is because inheritance is going to introduce another kind of relationship for us to think about. inheritance is used to describe an is relationship. So there are times in which there's kind of an overlap between objects, right? Sometimes there's objects that can do the same thing, right? That's not unusual. Or sometimes there's attributes that I would expect to find in many different classes. So for example, students have names, right? Employees have names, customers have names, right? All of those classes, all of those potential objects, I would expect to have an attribute called name. But actually, if we think about that for a second, where does the name originate from? Names are really applied to people. So in my person class, I have a name attribute, but students are people, right? A student is a person. A customer is a person. An employee is a person. So while it's true that all of those, customer, student, employee have the name attribute, it's really the fact that they are people, that they are persons that matters. And so that's where inheritance comes into play. Think about, if we actually wanted to make those classes, student, customer, employee, we could define the name attribute in each and every single one, but that's redundant. That is redundant, especially if we consider the fact that there's a relationship between those. They are people. They are human beings. So what we can do instead is we can inherit from other classes. I can make a class called a person class. And in that person class, I will put everything that is, shared across all people, right? Regardless of who they actually are in real life. And then I can inherit from that person class. So I can say that because a customer is a person, they will inherit that name attribute from the person class. So I don't need to restate that here. That's the benefit of inheritance. It allows us to acknowledge the fact that there are going to be relationships between our classes and allow us to put that combined code into one place, the attributes and also the methods. I'll talk about methods as well. Those are also shared via inheritance. All of that in one place, and then I can reuse that code in many other different classes. So let's start by taking a look at how this works in action, starting with a classic example from math class. We have a very, 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 very simple class here to represent a rectangle. So the attributes for our rectangle are length and width. That's pretty straightforward. We've got a couple of constructors here, one that just makes the default rectangle of size 1, and then another one that allows us to specify what kind of rectangle we wish. And then just this is not using standard draw. This is actually just printing out a rectangle on the command line on the console, just to keep things super simple, super straightforward today. And so, this is something that even 4th graders and elementary schoolers know, right? A square is a rectangle. That's quite literally one of the definitions from math class. It's a specialized version of a rectangle, right? Where the length and the width are equal to one another. But we can use inheritance to represent that fact. So in order to use inheritance, we're going to introduce a new keyword up here at the top, right? I'm saying that a square is a rectangle. In order to reflect that relationship in code, I would say that a square extends rectangle. And actually, just this alone does a whole lot of stuff for us. This is a point I'll revisit multiple times as we go through examples today. This is how we use inheritance. I want to make that clear from the start. If you see this extends keyword, that is inheritance. That is the representation of inheritance in code. What does that actually mean in practice? That means that any instance variables that exist in the rectangle class, as well as any methods that exist in the rectangle class, are carried over into the square class. They're just carried over automatically. I don't have to restate them in the square class, right? Inheritance brings them in for me, and then I can just use them as normal. Now there are a few little rules and restrictions we have to be aware of. Let's start by talking about the constructor. They want us to add a couple of constructors here. One to make a default square and want to make a square of a certain size, a particular size. So with the parameter, now, for a rectangle I take in two parameters, one for the length and one for the width, but for the square I don't have to do that, right? It's just going to be the length or the width, I guess whichever one you want, one or the other, but not both. And can somebody remind me again, what's the role of the constructor? What does the constructor do for us? Constructor's purpose in life is to do what? Yeah.
It defines the initial variable of an object, or it's just like what allows an object to create.
Yeah, you said two different things here, but they're both good. They're both great ways of answering that question. It creates an instance of an object. So a constructor, creates an object whereas before none existed. Right? Start with nothing, call the constructor, and now I have a square. That's what the constructor does for us. How does it do that? It does that by setting the instance variables, by setting all of the instance variables to a valid value. So in the rectangle class, we saw two instance variables called length and width, and you can see in both of the constructors, right here they're setting length and width to be 1. Here they're setting length and width to be the value of the parameters, which should be ints, not doubles. I can change that. Sorry about that. But in both cases, right, we're making sure that all of the instance variables get set. That's still true here. That is still true here. However, we have to recognize that the instance variables that we have aren't in this class. The instance variables that we have are coming from the class that we are inheriting from. The class that we are inheriting from. So, instead of, we could do this a few different ways. One way we can do this is we could actually try to set these instance variables here. So I could say this.length is equal to 1. Oh, but it doesn't like that. It says it's not visible. It's in a different class, and it's marked private. We talked about that last week. So that kind of makes sense. But another thing that we could do, and actually what we're going to do, is say, all right, a square is a rectangle, right? A square is a rectangle. So why don't I just call the rectangle constructor and let it take care of that stuff for me. Make it generate a rectangle that looks like a square. And so that might suggest that I'm going to do something like this. Plug in some values here. Or I guess new rectangle would be more appropriate perhaps. And we're getting closer, but this still isn't quite the right approach here. And it's because we're not using our inheritance by calling the constructor this way. We want to access the constructor by recognize the fact that rectangle is where we're inheriting values from. So I'm going to introduce yet another keyword for us called super. The word super refers to the class that we are inheriting from. So if I use the word super anywhere in this file, it's referring to rectangle. In fact, I would go one step farther and say that rectangle is called the superclass. And this class that I'm in right now, because it is inheriting from the rectangle class, I would call that a derived class. The square class doesn't just exist by itself, it is derived from the rectangle class. Yes?
Could you say that a derived class is always just like a more specific version of the superclass?
I think that actually is a great way of talking about it. The question was, is it safe to say that a derived class is a more specific version of the superclass? Yes, actually I think that is a very great way of thinking about it. We're kind of jumping ahead a little bit, but what we're really doing is making a hierarchy from general objects to more specific objects as we move down using inheritance. We'll talk more about that a little bit later. But yes, I think that's a great way of thinking about it. If I use the word super like this, what I can do is I can actually call the constructor by adding the parentheses and the arguments after it. By doing this, what I am doing, and I can prove this to you a little bit later with the debugger, is I am calling this version of the rectangle constructor, plugging in values of 1 and 1. So when you see the super keyword like this in code, it's referring to the base class, the super class, which is whatever is being extended. So this is saying call the rectangle constructor, plug in values of 1 and 1. For here, we have to do the same thing. I still want to call the constructor for the rectangle class, and I still have to plug in 2 values, but since this is a square, I'm going to just plug in the same value twice, right? I'm just going to plug in the same value twice. Okay? Now this is about as simple as it gets with inheritance. There is a lot of other topics that well, not a lot, but a few other topics that we have to talk about regarding inheritance today. But the main point that I'm trying to make here is that when I'm using inheritance, the first step that I'm almost always going to do is call the constructor of superclass. If I'm using inheritance, I'm going to call this constructor to take care of any instance variables from the superclass. Now where things get a little bit tricky, or trickier, if I want to, I could actually add more instance variables here. So I'm trying to think of more attributes that I might have for a square. I'm kind of coming up with a blank. So I'll just pick a very generic private string type or something like that, right? Sort of going off script a little bit here to illustrate this example. Our constructor, remember, is responsible for initializing all of the instance variables. So we have to initialize all of the instance variables from the superclass as well as the instance variables that are in this class, the derived class. So the super call takes care of initializing the instance variables from the superclass. We are still on the hook for initializing the other ones. So I still need to have some statement here that says, I don't know, I don't actually have a name for types of squares, but, or maybe color would be better. Yeah, I'll do color. That's an easier thing for me to talk about. There we go. Right? So this call takes care of the 2 instance variables from the base class. This takes care of the 1 instance variable that we've declared here. How many instance variables are there total for a square? There's 3. There's 3. 2 from the base class, and then this additional one that I added in the square class. Whereas a rectangle class just has the 2. Just has the length and the width. Right? No mention of color here at all. Down here for this constructor, if I want to, I could take in an additional string parameter, right, for color, and use that to set the instance variable. But the more important thing, I think, to remember here is that we're obligated to make sure all instance variables are set to a value. We're going to use the super keyword to set the instance variables from the superclass, and then we'll set the other instance variables just the same way we always have. Just the same way that we showed you last week. We haven't gotten to methods yet, but yeah, question?
Does this mean you can also set like public class rectangle extends square?
Oh, okay. So the question is, can we say public class rectangle extends square? So for starters, I'd like to illustrate that I'm glad you asked this. Using the is a relationship would say we shouldn't do this, right? Rectangle is a square. That's not true. That's an incorrect statement. A rectangle can be a square, but not all rectangles are squares, right?
For another example, like other than this specific rectangle square example, is there any squares for any kind of thing possible?
Well, let's talk about that, because let's say that I wanted to ignore, the relationship and just do it anyway, right? Let's say extends square. It's not going to let me do that. The error message that it says here is that the hierarchy of type rectangle is inconsistent. That's actually a very long way of just saying we have a situation that's circular inheritance, right? One class is inheriting from this class, and this class is inheriting from this class. That's not allowed. It's actually illegal in Java. You can't do this, and Eclipse is stopping me. Inheritance is a one-way street, right, in Java. Base class to derived class. Now, that being said, you can't have multiple layers. So, in fact, you'll see this on the studio this week. I can have one class as the base class, as a superclass, another class that inherits from it, and then another class that inherits from that, and then another class that inherits as many layers deep as I want to go, right? That's perfectly allowed, but it's a one-way street. I can't usually go back up with inheritance. Good question. Great question. Any other questions about dealing with instance variables before we switch and talk about methods? Yeah.
I have another question. So let's say if another class inherits the first inherited class.
Okay.
Does that mean all of the instance variables and methods that is incorporated in the previous two, like superclasses, won't be incorporated into inheritance?
Okay, so let me make sure I'm understanding your question right. I think you're asking, if I make another class, I'm just going to call it oops, I spelled that wrong, but I think you know what I was going for. Polygon extends rectangle, right? So I have two classes that are both extending the same superclass. Is that what you're asking about?
Is it possible for polygon extends square?
Polygon extends square? Yes, that's what I was just trying to describe. Yeah, having multiple layers deep, that's definitely possible.
So that will incorporate the information that is originally in rectangle and also modification.
Correct. Yes, it would inherit. So when you use extends, when you use inheritance, if I say extend square here, that means I get all of the instance variables and all of the methods from the square class. And we just talked about how the square class has 3 instance variables, right? I see one of them here. The other 2 are coming from the fact that it's using inheritance. This is allowed. That's perfectly allowed. Yep. In fact, you will see that exact scenario happen in Studio this week. But I'm going to delete this because they don't actually need it. I was just doing a little example. All right, cool. So that's the instance variables part of inheritance. Let's talk about the methods part of inheritance because there's some things that we need to discuss there as well. It's possible. Let me take a step back for a second. This is our superclass. So this is our class that we're going to be inheriting from. So if we just take a quick look at it, we can see that it's got a method for greeting. If I want to, I can plug in a name and it'll say hello to that person's name, right? There's a main method down here just to test it a little bit. There's another class that extends from it. So by extending this, we inherit all of the instance variables, but we also inherit all of the methods. All of the methods. So let me show you what I mean by that. I'm going to put a main method here. If I say greeter g equals mean greeter, oops, spelled that wrong. Can't type today. Whoops, I forgot a new keyword. There we go. Finally. Okay. So the mean greeter class has a method called greet. So does the class that it inherits from. The greeter class also has a method called greet. Right? Actually, it has 2 of them. So the question then is, which version of the method is this going to do? Which version of the method am I going to do here? Well, because I called this a mean greeter, this will use the one that is in this class. So I would expect it to say go away when I run this code. Oh, I need to print it. I'm sorry. Forgot a print statement. I'm only returning, not printing. There we go. Now I can hopefully, there we go. I got the go away. But with one change, if I change this to the base class, to the superclass, right? So now I'm not using the mean greeter, I'm just using the generic greeter. It's going to call the version of the method that exists here. So it's based on the object that is created, right? The way I had it before when I was creating an instance of mean greeter, it used this version. When I use an instance of just the generic greeter class, the superclass, and run this, I will get the version that's in that class. This is what's known as an overridden method, where we're overriding the method. Sometimes you'll even see this annotated as override. Right? What does overriding mean? Overriding means that this method was inherited from the superclass, but I don't want to use the version of that method that was inherited from the superclass. I want to do things differently. So when we inherit methods, we have the ability actually to kind of pick and choose which ones we want to keep and which ones we want to do differently. So if I don't have a problem with the methods that are inherited, I just leave them alone. But if I want to do something differently, I can override that method and provide a different version of it that will be used for this class. What I want you to notice is that if I plug in a name, all right, so there's this method here that says, all right, if I plug in a name, it'll say hello to whoever that person's name is. And if I run this, whoops, I ran the wrong file, I'm sorry. I meant to run this one. There we go. It says hello to me because I used the greeter class. But what if I switch this to say mean greeter? There is no method like this in this file, right? There is no method that accepts somebody's name and says hello to them in this file. But that's not a problem, because this class has inherited that method from the greeter class. So we can access it that way. And if I run this, I'll actually see the exact same thing as I did before. It says hello to me. So let's think about what that means. I can have a method that exists in both the superclass and the derived class, right? So if I create an instance of the superclass, I'll do the version that's in the superclass. If I create an instance of the derived class, I'm going to do whatever's in the derived class. If I have a method that exists in the superclass that does not exist in the derived class, I did not overwrite it. I did not provide another way of doing it. Then the derived class will just use whatever version is inherited from the superclass. Does that make sense? I hope. It is some, again, an abstract concept. Yes?
Quick question. So which part determines, like, which one to use, like, mean reader or reader? So
Perfect. Yeah, very glad you asked that question. Which part determines which one we use? This is the important part. You're probably a little bit confused because I didn't change this over here, right? I don't want to assume, but I mean, I left this the same. Think about it for a second. A mean greeter is a greeter. We've defined that by inheritance. So leaving this as the generic type is fine, because this thing is one of these. This contains all of the instance variables and the methods from this class. So I know it can do all of that stuff, right? The opposite is not true. If I have this as a derived class,
like rectangle equals to
right, yeah, I can't do this, right? This is not one of these. That's a backwards inheritance relationship. But the original way that I had it, this is actually a very, 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 very powerful concept, actually. In fact, we have a name for this concept. In fact, we're going to talk about it a little bit later on. Polymorphism. This is illustrating something called polymorphism. Yes?
So we're calling, although the two Greek methods they have the same name, because the variable we're using in the method call is that, I mean, it's not variable. The object G we're using that is declared as object as
I'm not sure I followed that question. I'm sorry.
So when we create and initialize the G object,
Yes.
we're using creator class to declare it,
Mm-hmm.
and then we're using G dot greet because greet method is present in both creator and greet. Like, is it because so that it actually execute the method in the creator class? Is it because that G is declared in the creator class?
It has everything to do with this. This is what determines what version of the method gets called, not this. This. Yes.
Say just G starts out being creator, right? Just talks about creator.
Correct.
Okay, cool.
Yep. I look for the method here first. If I don't find it, then I'm going to go check the superclass and see if it's there. Yep, that's right. That's exactly right. Also notice that I don't need this at all, right? I can take this out. And now this entire class, I mean, it's not doing anything. This is basically useless. But the entire class is just pulling methods from the superclass now. I'm not overriding anything. It's up to us to decide when we want to override something or not. So if I don't have a good reason to override a method, I'm not going to. That's the easiest situation, right? I only override a method when I've decided that the way that that this new class does it has to be different than the way that the superclass does it. Okay, I can change that behavior by overriding the method. And this is actually a pretty common thing to do. It's nice to be able to override some of the methods and not all of them, and just use the originals from the base class for ones that you need to. Any other questions? Happy to go over any of this again. I know it's tricky. I know it's complicated. Abstract. Very abstract. Okay. We're going to talk about the super keyword again. But this time we're going to do it a little bit differently. Let's see. I want to look at this person class. So this is the base class, the super class. The person class, we're keeping it very simple, has a name, and then it has a method called getFood, and we're just saying that all people like hamburgers. I know that's probably not true. In fact, I know it's not true, but you know, this is a very simple example. For the student class, if I come up here, you can see that we're extending the person class. I'm actually not going to talk about the ID number much, except to illustrate, again, the fact that I can introduce more instance variables here if I want to, right? So this student class has these instance variables plus the instance variables that it is inheriting from the person class. So it has the ID number and the name. But what I'm more interested in is actually this down here. This is another instance in which we have overridden. So this is another case where we're overriding a method from the superclass. And what we're saying, this line here actually shows us, there's that super word again. It looks a little bit different than last time. So last time we saw super used. We did it kind of like this, where I said, you know, super, and then put parentheses after it with parameters in the middle. This is for the constructor. But what we're doing here is saying, all right, first I want you to do the getFood method from the superclass. Give me that answer. And then I'm going to go and do some extra stuff after that. So this allows us to utilize the existing code from the superclass as well as make some modifications to it. I haven't used the debugger yet today. I think today might be a good time to do that. I'm going to set a breakpoint on this line right here, line 19. Line 19. And start my program. So the first thing we're going to do is we're going to create a new student, a new instance of the student class. Notice that over here it says person, because a student is a person. So that's perfectly okay. All right, I'm going to go ahead and do that. And now it's going to say, get the food that this person likes. When I step into it, where am I going to go first? Which class? I have two getFood methods, one in the person class and one in the student class. Which one am I going to look at first? Student. That's right. because this is a student. This says student here, so this is going to take me to the student class. If this said person, then this would take me to the person class, right? But it doesn't. It says student. So we're going to, when I step into this, I expect to go to the student class, and I do. And I do. But then this line says, okay, I want you to call the get food method from the superclass. So now I'm going to go to the superclass. It says return hamburger. All right. I come back to the student class. I see that get food returned hamburger. Output is now equal to hamburger. So I'm going to take that result from the superclass and tack on a taco, right? This is a very silly example, but it does illustrate the concept just fine. And then when I print that out, you'll see that I have both. So we can use the existing version of a method from the superclass in our derived class. The main point of this example was to illustrate that this super keyword can be used in multiple ways. Now, I want to make it clear. Let's talk about how this happens in practice. The super keyword in practice, at least in my personal experience, I'd say probably 9 times out of 10, I'm using it in the constructor. I don't see it used this way as often. It does happen. It does happen to see it in a method that is not the constructor. That is absolutely a possibility. It can be useful. But more often than not, that super keyword is being used in the constructor to initialize instance variables from the superclass. Any questions about overriding methods, super keyword? Got a couple more things I want to chat with you about regarding inheritance, but if anybody's got any questions, okay. Then let me stop the debugger because I think I'm done with that example, and we'll move on to the next one. Don't know why that got closed. Perfect. Actually, I think this example is more of the same, so I'm going to skip that and move down to polymorphism for our next topic. We're going to do a lot more code writing for this example. This is going to be a fun one for us to work with. Let's start by taking a look at our superclass. I have a class that represents an account, presumably at like a financial institution, like a bank or a credit union or something like that. There's a name associated with the account. I'm assuming that's the name of the person who owns the account, but it could be some other name, I suppose. And a balance, how much money is in this account, right? And the account itself, very generic, doesn't do a whole lot of stuff, but it could, right? In fact, one thing that I know accounts can do, some actions. This isn't directly related to inheritance, but I'm going to do it anyway because I think it's an interesting little example for us. They can deposit, right? They can also withdraw. These are typical actions that I would expect to do with bank accounts, right? In fact, for this one, I'd probably indicate a double. For this one, I probably want a double in. For how much, actually here, I probably want the same. For depositing, I just need to say, how much they're taking in and add it to the balance. So I could say something like this dot balance plus equals how much, right? Take whatever's coming in and add it into the balance. For withdrawals, we have a little bit more work to do because, I could go down to the bank right now and say, I'd like to withdraw $1 million, please, and they're not just going to gladly hand me $1 million, right? I don't have that kind of money. They're going to be like, sorry, sir, you don't have enough. You don't have $1 million. We're not going to give you $1 million. So we need to do a check. You need to do a check first. Do they actually have enough? If the amount that they wish to take out is less than the amount that they have, right? If the amount that I'm asking to take out is less than the amount that is currently in my bank account, then perfect. I will subtract the amount and return that amount, right? Give you that money. Otherwise, we have a choice to make. How do we deal with this? There's a few different ways I could consider handling this option. I could say this is an error. I could say, hey, look, you're not allowed to do that. You're not allowed to ask for more money than you have. That's a mistake. That's an error. That's not allowed to happen. Or I could say, you asked for more money than you have. I'm just not going to give you anything. $0 back. Sorry. Not going to help you. Or, I mean, another way could be, you ask for more money than you have. I'll just give you everything that you have, right? You ask for $1 million, you only have $100, I'll just give you your 100. I think all options are perfectly acceptable. We just need to pick one. So I'll pick just returning 0, right? If you ask me for more money than is in the account, I'm just not going to give you anything. Just say, whoop, sorry, bad request. Can't help you. None of this has anything to do with inheritance yet. It will, I promise. I'd like for you to consider the fact that there are more than one type of account in the world. So there are savings accounts and there are checking accounts. Those are the two biggest kinds of accounts that you hear about. One of the nice things about savings accounts, or it used to be nice, not so nice anymore, if you have money in a savings account, you get interest. You get interest on that. That's typically not true of a checking account. You don't get interest on the money that's in the checking account. What benefits do you get for a checking account? There are many. That's kind of what banks are trying to sell you on. But one of the main ones that I can think about is that a checking account, I'm actually allowed to overdraft. I'm allowed to temporarily take out more money than I have, right? It'll let me go into the negative at least a little bit. They want me to pay that back later, and they're probably going to charge me a hefty fee, but I can do it, right? So how do we reflect that fact in our code? Let's do it. Let's spend some time, making classes for savings account and a checking account that can take those differences into play, and we'll use inheritance to do it. A savings account is an account, right? So having it extend the account class is not an unreasonable thing to do. And by doing that, again, I want to reiterate that that means I inherit all the instance variables as well as all the methods. So I got the name instance variable, the balance instance variable, as well as the deposit method and the withdrawal method. Right? Those things all come along. If I want to, I can add additional instance variables. And in this case, I think I do. The difference that I mentioned between savings accounts and just any old account is that they have an interest rate. So I'm probably inclined to include that interest rate here, which has some follow-on effects for when I make the constructor. What did the constructor for the account class look like? It takes in the name and the balance. All right, cool. So I'll take in the name and the balance, but I also need to take in an interest rate. Make some more room here so we can hopefully see. These two are inherited. So in order to accommodate that fact, we're going to let the superclass take care of those two, right? I'll just call super, and I'll plug in the two that come from the inherited class. That takes care of those two. And then for the interest rate, I'll just set that normally, right? Why are you angry at me? Let's see. Oh, I forgot a letter up here, didn't I? Ooh, that was a tricky one. extend instead of extends, plural, and that caused all those errors. Woof, that was just one letter off, and the whole thing is like, I don't like this anymore. That's computers for you. Very, 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 very picky. Very, very, very picky machines. Put that S in, and now everything's happy again, just like that. One little typo. So again, I'd want to reiterate that this savings account constructor, its role in life, its job in life is to make sure that all of its instance variables are initialized. These two are taken care of through the superclass, through inheritance. This one is just taken care of in the normal way, since it's in the savings account class directly. Now the other difference, that we might want to accommodate is I have to compute that interest. And I'm not a finance person, but I know enough about it to say that this is called compounding, right? That's about all I know about finance, to be honest with you. And so I would probably come down here and say public void compound interest, right? This is a method that only applies to the savings account class. This method is only going to exist in the savings account class, right? Compounding interest is not something that I need to do on all accounts, only on accounts of this type. So I can keep this code where it is most needed instead of, in the superclass. And so I'm not so worried about the math, but, something like this should get the job done, right? Oh, here's a tricky problem, though. Maybe you can help me with this one. It's angry. Why is it angry? It says the field account.balance is not visible. We've talked about this before, though, right? This is marked private, as it should be. That means I can't see it outside of the file, but I need to do something with it here. Any ideas how I can fix this? How did we fix it last week when I ran into this problem? I used some methods with rhyming names. One starts with a G, one starts with an S. There you go. I need some getters and setters for this. So instead of accessing this field directly, we need to have some getters and setters for this. So all right, I showed this to you last week. I'll show it to you again because I think it's a good thing for you to know how to do. I'm going to have Eclipse generate a getter and setter for me. Generate getters and setters for balance. I need both. I need both the getter and the setter because I am trying to both. Oh, whoops, that's the wrong file. Sorry. I have too many tabs open. There we go. I'm trying to both read the value and change it, right? So this statement is actually going to become a little bit different. Here, let's try this. Double new balance is equal to this dot get balance plus this dot get balance. And then to update our balance, I'll just say this dot set balance to the new balance. There we go. Without those getters and setters, it wouldn't work because those instance variables are marked private. But we demonstrated a need for them, so we can put them in. That's another thing that I kind of want to help build in you all, is the confidence to do this, right? For a lot of the homework assignments, we tell you, make this method, make this method. It should look like this. It should do that. Nobody's telling me what my methods should look like. Nobody's telling me what methods I should write. So after you get out of class and you have to make a program on your own, you need to have that confidence. You need to have that confidence. Oh, I need to be able to do this thing. I might need some getters and setters to do that. Let me put those in. Let me make this method. All right. We're going to do this again, focusing not on the savings account, but now on the checking account, and then we'll try to tie it all together. I'm going to make a checking account class. A checking account can also deposit. Checking account can also withdraw, right? Checking account also has a balance. You know, the point I'm trying to make is that I think a checking account also is going to extend the account class. Think about that for a second. Got two different classes, both inheriting from the same superclass. That's okay. That's a good thing. I like that. That's nice. The difference that I spoke about with the checking account, there are lots you could choose from, but the one I'm going to focus on for today is the fact that it allows me to overdraft. It allows me to take my balance below zero, right? So, same thing as before. Need to think about what instance variables I need. I don't think I necessarily need any instance variables for this. Maybe there's like a fee associated with it or something, right? That you could make. Overdraft fee could work, right? I'm not sure that's even necessary for this example, but you could certainly do it. And then we'll turn our attention to the constructor, as we usually do. Just like we saw with the savings account, we're going to need the two values from our superclass, as well as this new third one. And just like we saw in the savings account class, I'm going to use the constructor from the superclass to handle the first two. And I will handle the third one, since it was created in this class. I'll just handle it directly. Oh, whoops, that's not right. There we go. Now, the overdraft, when does that happen? That happens when I withdraw. An overdraft occurs when I withdraw too much money. So I have $100 in my account, I ask for $125, right? And it says, okay, I'll put you at -25 for, you know, $20 fee, right? And then it goes through. But the original code that I have for withdrawal won't let me do that. If I look at the code for withdrawal that I have in the account class, it only lets me take out what I actually have. It doesn't let me go below zero in my account. It won't let me do that. Actually, most banks won't even let you go to zero, right? They'll only let you go down to like $10 or $5, and they'll stop you there. But for this one, we want to allow us to go below zero. We have to override this. We have to override this method. It does most of what we want it to do, but it doesn't do all of what we want it to do. We want to allow this to go below zero. This method does not accurately reflect how we want the checking account to handle withdrawals. So let's override it. The biggest difference, I think, is actually right away in this if statement, right? That's the biggest difference. So it's really if how much is less than this dot balance plus 50, right? Let's say allow 50 overdraft, right? If I have $100 in my account, I'll let you withdraw up to 150 bucks. That's what I'm trying to say. Maybe I should say less than or equal to, right? Then I will return how much? Oh, I need to set the balance, don't I? I need to do some math. There we go. Notice that because I'm in a derived class, actually here too, I need to use the getters and setters. Otherwise, we'll do the same thing. We'll just, you know, if I ask for too much money, then okay, I'm not going to give it to you, right? If I have $100 and you ask for $1 million, I'm still not going to do that. I might give you $150, but I'm not going to give you $1 million, right? That's way too much of an overdraft. Oh, I guess we also need to take that fee into account, right? Minus, I almost forgot. The bank wouldn't forget, I guarantee you. They're going to get their fees no matter what. I almost forgot. There we go. What are you unhappy about now? I'm a little bit confused where my error is. Let me think for a second. There we go. Yeah, I forgot to save the file. That was my fault. Okay. So we now have two classes that are inheriting from the account class. One of them just adds an instance variable and a new method. The other one added an instance variable and overrided a method, right? Changed how the withdrawal works. Notice that the withdrawal is going to work just the same for a savings account. We didn't change that behavior at all. We only changed how the withdrawal works for the checking account. That's great. That is a wonderful thing about inheritance. Without inheritance, think about what these two classes would look like. I would have to define withdrawal and deposit in both of them, even if they worked exactly the same way. That's what I would have to do without inheritance. Inheritance lets me take that common stuff, put it in one place, and then reuse it across every class that is doing the inheritance. Now to wrap this up, the final thing that I want to show you today is an illustration of polymorphism and kind of, you know, the grand finale. Why do we do this? Why do I spend all this time talking about inheritance? What does it help us with? What is it good for? Well, where do all these accounts live? These accounts live at a bank, right? So let's talk about a bank for a second to wrap up our day today. I'm going to make a bank class. And so the question is, all right, whoops, sorry. There we go. Bank has some accounts, right? A whole bunch of them, as a matter of fact. But what kind of accounts are they? Are they checking accounts? Are they savings accounts? Well, it's some of both, right? Some of both. So, you know, I want to make an array of accounts. You hopefully saw this in assignment 7. You make an array of students for your course class, right? We can do the same thing here. But, you know, if I make an array of savings accounts, private, forgot the private word, right? Then I can only put savings accounts in here. I can't put checking accounts in here. And the same thing's true if I say checking account here. If I say this, then I can only put checking accounts in here. I can't put savings accounts in here, right? What if I want to do both? I mean, clearly both exist. One way might be to say, all right, I'll make two arrays, one with checking account and one with savings account, right? And all right, that's not necessarily the worst. Did I misspell it? Oh, I did misspell it. That's not necessarily the worst solution in the world, but we can do better. We can do better. I can do this. By having the type of the array be account, that's the superclass, right? A savings account is an account. A checking account is an account. I can put either a savings account or a checking account into that array. I can put anything that inherits from the account class into that array. In fact, I'm not going to write out the whole bank class. I don't have time to do that. I think it's kind of a cool exercise if you want to take this and even farther than what I'm going to have time to show you today. But instead, what I'm going to do is just throw in a quick little main method here. I'll make an account array. Oops, before I do that, actually, let me make some accounts. Here is my savings account with $100 in it and an interest rate of 1% because whatever. And here's my checking account. With $200 in it and an overdraft fee of $20, okay? And the claim that I'm making is that I can do something like this. Account array there we go. This is something that we have not been able to do before today. When I make an array that has a type, the only thing I can put in an array are things of that type. Period. We now have the ability to refer to a class by either the type that it actually is, savings account, or what it inherits from, the superclass account. This is called polymorphism. I have the ability to refer to an object by either the class that it specifically is, the derived class, or the base class, the superclass that it inherits from. I can use more than one type to refer to the same instance. Another way to think about it, I am a person, right? Person class applies to me. I am an employee of Washington University. Employee class applies to me, right? I am an instructor. Instructor class applies to me. So there are, in fact, more than one type that can apply to a single instance of an object. When I'm on campus, the instructor type is very appropriate, right? The employee type is very appropriate. When I go home, I'm just a person. I'm just dad, right? My kids don't call me Professor Shook. That would be really weird. So those classes aren't appropriate, and they treat me as just a generic person. We have the same ability to do that in code, and it's actually very, very, very valuable. Consider, let's say your bank is feeling generous and wants to give $10 to everybody just because they can. I can now do this all in one go. Right? I can iterate through this accounts array and deposit $10 in each account. Do I know if I'm making this deposit into a checking account or a savings account? Nope. Does it matter? No. Because I know that both checking accounts and savings accounts are capable of depositing. How do I know that? Because both of them inherit from the account class. And because the type of the array is given as accounts, I know, even if it's a savings account, it can still be deposits. Because savings account inherits from account class. I know, even if it's a checking account, it can still be deposits. Because checking account inherits from the account class. Polymorphism is a very, 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 very powerful tool that allows us to group together objects of different types as long as they utilize inheritance. Are there any questions about that? I know this is all very abstract. I know this is all new stuff. Would be happy to explain any of these concepts over again. Although, to be honest with you, I think I probably yacked on enough. I think really to get the hang of this stuff, practice. Practice is what's important. So here's what you've got to look forward to later on this week. When you come to the studio, you're going to be making a quiz. You're going to be making a little quiz application, and you're going to be using inheritance to do it. So quizzes that can handle multiple types of questions. Fill in the blank questions, multiple choice questions. All of them are questions though, right? So you have a question-based class and then multiple types of questions that inherit from it that you can use to create a quiz. That's all I've got for you for today. If any of you have any questions, I'll be happy to stick around and chat after class for a bit. Otherwise, I hope you have a good rest of your week, and I'll see you in the labs on Wednesday and Thursday. Thanks, everyone.